I'm going to give you a quick intro into the basics of spectra that you're going to be using for the gizmo activity on evaluating star spectra. What I want to look at specifically is what the rainbow spectra mean and where they come from. How do we get these rainbow spectra? So specifically, what you're going to see in that little gizmo activity is the absorption spectrum. So that middle bar that you see there. You may also see the emission spectrum, but specifically we want to be looking at not a continuous spectrum, but one that actually has some breaks in it, some black lines that you observe. In order to talk about spectra, we need to quickly look at electromagnetic radiation. Now, we're going to dive in deep to this in about 2 weeks, but the basics that you want to know about electromagnetic radiation is this is really energy that travels and spreads as it goes. An easier way to think about it is it's basically all of that light around us. Now, I don't just mean visible light, because if you look at that table, visible light is part of the electromagnetic spectrum, but we're also talking about radio waves, microwaves, infrared waves, ultraviolet, UV rays, X-rays, and gamma rays. All of those are considered, electromagnetic radiation, not just visible light. But we are going to take a look at visible light right now because that's the light that we can see with our eyes. And so it's easier for us to understand where that spectra is coming from, where that rainbow spectra is coming from when we look at it from a frame that we understand, which is visible light. So basics of spectroscopy, and this is how you come up with those spectra, the rainbow lines with the black breaks in it. The way that we come up with those is using spectroscopy. Now, spectroscopy, what it does is it actually disperses electromagnetic radiation. So we're going to look at how it disperses visible light. Now, you've seen this. If you've ever seen prisms, right? So a prism will take the light in and it will disperse that light into basically the colors of the rainbow. So what we're looking at with spectroscopy, when we're looking at how we got that spectra, is there's some emitter. In our case, for this next activity, that emitter is a star. All right, so the star emits its electromagnetic radiation, all types of electromagnetic radiation, not just visible light, but all types. And we can evaluate how that goes through some kind of matter, say a prism, kind of like a prism. And then that spectra, the resulting like rainbow spectra, is evaluated by a spectrometer. And that data is read to actually figure out what is the structure of the atoms and the molecules in that electromagnetic radiation that was emitted. So by using this process, we can actually figure out what are the elements in the outer part of stars, right? And so that's what we're going to be looking at. And this is just a reminder of a prism when you shine the light into it and it disperses that electromagnetic radiation into the colors of the rainbow. So that's just a brief overview of what it means when you're looking at this spectra to do that gizmo that you're going to work on. I hope you have a wonderful day, and I will see you next time.